So guys, here we are with assignments on electromagnetic theory. So I'll be sharing with you the assignments. You can find the PDFs of these assignments on our Telegram channel, Telegram group. The link of the group is given in the first comment, okay, or pinned comment. You can check it out. You can join the group and you can download the PDFs. So I will not be solving the questions in very detail. I will just give you hints, and based on that you can just solve the problem, and I will also share the answer keys. Although the answer keys are attached in the PDF of the assignment, so you can also get it from there. I will just share with you the method, the way in which you can solve these problems. So this is your first assignment from electromagnetic theory from the detailed plus course. The plus course link is also given in the first comment, so you can check it out. And if you want to join our Unacademy Plus classes, you can join it. You can utilize our referral code PhysicsHub PHYSICXHUB to get the maximum benefits while taking Unacademy Plus or Iconic subscription. So these assignments are from that particular course. So this is the first assignment, EMT assignment 1. Okay, so each assignment contains 10 problems, and in each video 5 problems will be taken at a time, so that the video doesn't get much longer. So let's start with the first problem. You can get the question paper on our Telegram group. So look at the first problem. The 2-point charges Q1 of 1 nanocoulomb and Q2 2 nanocoulomb are kept in free space such that the distance between them is 0.1 meter. So this is the first assignment, very basic assignment from the topic electrostatics. These assignments are from electrostatic, first assignment. So these 2 charges are given to you. Now 4 statements are given, and out of these 4 statements, which statement is correct? The force on Q2 is along the direction from Q2 to Q1. Force on Q2 is same as magnitude as that on Q1. Net force, the force on Q1 is attractive. Point Q3 placed at the midpoint between Q1 and Q2 experiences no force. So you know that according to Coulomb force law, whatever be the force experienced by Q1 by Q2 and Q2 on Q2 by Q1, those forces are equal. Force on 2 due to 1, the magnitude is same as force on 1 due to 2. This one we know from Coulomb's law. Okay. So keeping this point in mind, what should be the appropriate answer for this question? You will get option B to be the correct option. The force on Q2 is same as the same in magnitude as that on Q1. So B is the correct answer for this question. Let's quickly move to question number 2. Question number 2 says 3 charges are located on the circumference of a circle of radius r as shown in figure. So 3 charges you are given. Okay, this is a circle, although my drawing is not that good, but try to understand the basic of the question. So 3 charges QQ and Q, it is given to you, and these 2 things are making an angle of 90 degree. The 2 charges Q subtend angle 90 degree at the center of the circle. The charge Q is symmetrically placed with respect to the charge capital Q. If the electric field at the center of the circle is 0, what is the magnitude of capital Q? So you have to find out the magnitude of capital Q. This is very simple. Electric field at point, let's say O, this is 0. So what you can do, these are positive charges, so electric field will be outward. So this will be the direction of the electric field for this. This will be the direction of the electric field from this. Okay. So let's say this is okay. So this is also positive charge. So the direction of electric field will be like this. This is, let's say, E1, and for this, let's say this is E2 and this is E3. So these are the components of the electric field. Now E3 will have 2 components, one along this, another along this. E2 will have 2 components, one along this, another along this. So you can see these horizontal components get cancelled, only the vertical components remains. So if this angle is 90 degree, this angle will be 45 degree. Okay, this is 45, this is also 45. So E2 plus E3 cos 45. This is acting in the lower direction. This should be equals to the magnitude of E1. so that the net electric field at this point O is 0. So, utilizing this thing, you can easily calculate the value of capital Q, and it will come out to be Q by root 2, which is matching with option A. Okay. So, this is very simple problem. Let us move to the third problem, question number 3. Let us do it. A thin semicircular ring of radius r has a positive charge Q distributed uniformly over it. So, this is I cap given, this is J cap given to you. ओके थोड़ा सा इसको ऐसे ड्रॉ करना चाहिए, स्मार्ट बोर्ड होता तो अच्छा होता गाइस. So this is J cap and the charge Q is distributed over a thin semicircular arc. This charge Q is distributed over it. This is, let's say, the point O. The net electric field at the center O is. So what you can do to solve this problem? It's a very easy problem. So you can see we can take an infinitesimal element here, and because of this will be the direction D. Let us say this is the dq element. Because of the dq element, the electric field is D. Now let us see which of this thing is surviving and which is not, and this element is lying between the theta and theta plus d theta. Okay. So if this angle is theta, so what will be this and what will be this? So it is basically two components of the vector. One component will be dE cos theta, another component will be dE sin theta. Now you consider another element which is symmetrically opposite to this, so somewhere here. So if you consider a symmetrically opposite element, this will also give you two components, one is along this, another one is along this. So you can see these horizontal components, they are cancelling each other, only the vertical components are adding up. So basically dE sin theta is surviving. So if you integrate this d sin theta over dE sin theta over the whole semicircular arc, so d sin theta, it is directed in the negative j cap direction. You can see this is a positive j cap direction and the electric field direction is the negative j cap direction. So if you integrate it over this thin semicircular arc, it will give you the total electric field value. I have used a vector sign, so I am giving a vector sign. So in this way you can do it, and you will find option C to be the correct option. For this question, option C will be the correct option. So look, I am just explaining you the overall process or approach. If you are facing any difficulty in solving this question, you can let me know. I will try to upload a detailed solution of that particular video. So without any further ado, let us start the fourth problem. What does the fourth problem say? What is the volume charge density of a uniform infinitesimally thin spherical cell of radius r and charge q centered at the origin? You can use the Dirac delta function. Okay, so you are given a spherical cell. This is the spherical cell of radius r and charge q. So spherical cell, for the spherical cell, you know, whatever be the charge that resides at the outer surface, right, q is uniformly distributed over the, so there is no charge inside the spherical cell, electric field is 0 inside the cell. So you have to find out the volume charge density. Okay, so look, basically this is a surface charge, but you have to express it in a volume, in terms of volume charge. So what you can do, we can consider a function, let us say rho of r. Let us say we are writing it a times delta r minus r. Can you write it? What does it mean? This is the Dirac delta function. It will give you a non-zero value only when you put small r is equals to capital R. Small r is equals to capital R means it is denoting the surface, because at the surface your small r is capital R. So in this way we have expressed the surface charge in terms of the volume charge. Now the total charge is given to you as q. So q can be found out as rho into d tau, right? Rho is this function, and a times delta r minus r. So, it is only function of r. So, d tau we can put 4 pi r square dr. So, by solving this you can find out this unknown constant A. Once you get the unknown constant, you can easily put it here and you will get the volume charge density in terms of this Dirac delta function. So, after you do this, you will get option A to be correct. So, option A is the correct option for this question. So, it's a simple problem, only you need to keep some, you need to use some special trick or special knowledge. This is not trick actually, it is the basic concept. So, let us now move to the next question, question number 5. What does question number 5 says? If the electrostatic potential in a spherical polar coordinate is phi of r, phi naught e to the power minus r upon r naught. This is given. Phi naught and r naught are constants. Then the charge density at distance r is equals to r naught. This is very simple. You can utilize Poisson's equation. Grad square r is equals to minus rho by epsilon naught. Okay, and this is the Laplacian. We can express it in spherical polar coordinates. You know the formula. You write it, and this is del grad square phi, and put in place of phi this expression phi naught e to the power minus r by r naught. So, once you put this, you will get an expression of this, and from that you can easily calculate the value of rho. You have to find out the value of rho at r is equals to r naught. After evaluating the expression, you put r is equals to r naught, then you will get the answer, and it is matching with, it will match with option A. Option A is the correct option for this question. Okay, so this is the 5 question from the assignment 1. The next part will be uploaded very soon. So if you want to get this PDF, you can join our Telegram channel from the first link, and if you are new to this channel, please subscribe the channel and don't forget to press the bell icon. Finally, thanks for watching. Unacademy is India's largest online teaching learning platform. You can prepare for various competitive exams like CSIR-NET, GATE, JEST, IIT-JAM, TFR. Especially if you are preparing for CSIR-NET Physical Science, you can join me on Unacademy Plus. I cover all the 9 units of CSIR-NET Physical Science syllabus. My approach is especially, I precisely give you the concept of the concerned topic. Then I discuss the relevant mathematical formula and do the analysis. Relevant problem based on the topic, including previous year questions, are discussed. Homework and assignments are also given. This is my profile, and if you want to join my Unacademy Plus courses, you can enroll for this course. And if you are new to this Unacademy platform, you can take Unacademy Plus subscription using our referral code FELIXUP, and Unacademy will give you 10% off. So take the Unacademy Plus subscription today and put your feet one step ahead towards reaching your goal. Thank you.